So the directions say consider the table at right, and they want you to write an equation for the function represented in the table. So it's linear. See if you can figure out the equation for that function. I'll give you a little bit of time to do that. Don't type it in the chat right away in case other people still need time, but try to find the growth and the starting point, the y equals mx plus b. All right, does anyone want to share their equation that they came up with? Anyone? So a couple ways to kind of go about this. You can try to figure out what the growth is, the slope. How much does x grow? How much does y grow? So you can see x is growing by 2 and f of x. So it goes up by 2's here. And then f of x or y is growing by 12, which lets you know that your slope is 12 over 2 or 6. And then if we kind of work backwards in our table, our starting point at 0 would be negative 11. You could check a point. 7 times 6 would be 42, minus 11 gives you 31. Plug in 5, 6 times 5 is 30, minus 11 gives you 19. So we want to, so if we think about this, kind of the steps here, the first step is multiply by 6. And then the second step is to subtract 11. So for B, our inverse, so the first thing the book is asking us to do, if you're not reading it, is to make the table for the inverse. To remember a function and its inverse, the tables just switch, the x and y. So this would be negative 5, 1, 7, 3, 19, 5, and 31, 7. So for C here, again, we're going to take these steps and we're going to do them in the reverse order and the opposite. So the first thing we would do instead of subtracting 11 would be to add 11. And then instead of multiplying by 6, we would divide by 6. So the inverse, again, add 11, take that whole thing, divide by 6. Okay, so we're gonna kind of do problems 40 and 41 as notes here, I think, rather than taking notes separately at the end. We'll just use these kind of as our examples here. So the first one is f of x equals 2 times the quantity x minus 1 cubed.
Mommy.
What, Forrest? No.
Why, mommy? Why? Why, mom?
Because I'm doing my class. So, I should have labeled this table first.
Can I sit on your lap?
So for our table, we'll go ahead and just go from -1 to 3. If you have a graphing calculator, you can get the calculator to do the table for you. If you hit y equals, just to kind of show you how, I would type that equation, 2x minus 1 cubed. And then hit the table button, the second graph, and it gives you the table there. Let me zoom in a little bit so you can see it, rather than having to plug the numbers in yourself, which you can still do, but you can get the table from a graphing calculator. You can also get it from Desmos. So at -1, we're at -16. At 0 is -2. 1 is 0. 2 is 2. And 3 is 16. So then for inverse, again, we're just going to flip them. Remember, the notation is the -1 there. So -16, -2, 0, 2, and 16. -1, 0, 1, 2, and 3. That's for the inverse. So you can see we just switch the x and the y. Then we're going to go ahead and graph this, the ones that fit at least. So 0, -2, 1, 0, 2, 2. These should be curved. I'm trying to curve it, but it's not quite working. And then our inverse, -2, 0, 0, 1, 2, 2. Go sit on the couch, please. Remember, for our graphs here, it's symmetric to y equals x. That's the line of symmetry. And then lastly, for the equation, the first step to looking at the original is to subtract 1. Then we cube it. And then the third step is to multiply by 2. So for the inverse, our first step, instead of multiplying by 2, we divide by 2. The opposite of cubing something is the cube root. And then add in 1. So that gives us the equation x divided by 2. Then we take the cube root of that whole thing, and then we add 1. That plus 1 is not inside of the cube root. And then to check your inverse, remember we pick a number, we plug it in, and then whatever we get out, we test or we put back into the inverse. So I'll just check. I'll just say, I'll pick a random one, x equals 10. Usually I use 0, but 0 is in our table, so I wanted to just choose something different. We are going to end up with a really big number here. That's okay. So, oops, f of 10, not f of x. F of 10 is 2 times 10 minus 1 cubed. So 2 times 10 minus 1 cubed. I get 1,458. So for my inverse, that's what I want to plug in, 1,458. All right, so math, cube root of 1,458 divided by 2, and then plus 1. Again, on your calculator, you use the over arrow to make sure the plus 1 is not inside that cube root, and I get 10. So it worked. So remember whatever your original input was, that's what you want to be the output when you switch the input and output. All right, and then we'll go ahead and actually do problem 42. 41 was talking about checking the answers. So this is kind of 5-41, but we're just doing all of it as notes, so it's not a big deal. Our second example we're going to use here is f of x equals x minus 3 squared plus 2. So the first thing I want to say here, we know that this is a parabola. Everyone in here should know this. It has a squared on it. So this is what we talked about yesterday. The inverse will not be a function. So we need to restrict the domain. So remember, this is a parabola. And then what we saw yesterday is when we do the inverse, we have a sleeping parabola, that sideways parabola, which isn't a function. So in order to make our inverse a function, we have to restrict the domain. So if we think about this parabola here, our vertex is 3, 2. That's our HK values. So our domain that we're going to look at is when x is greater than or equal to 3, and our range isn't restricted. It would just be y is greater than or equal to 2. So again, think about this parabola. The vertex is 3, 2. So I'm just going to kind of sketch it so you can see what I'm talking about. So it would look like this, something, and we only want to focus on half of it. So since this point is 3, 2, we're just going to look when x is greater than or equal to 3. So 3, 4, 5, 6. At 3, we know we get 2. That's the vertex. So again, filling in this table, I can either plug them in one by one, or I could use my calculator or Desmos. 4 minus 3 is 1, squared is still 1, plus 2 is 3. 5 minus 3 is 2, squared is 4, plus 2 is 6. And then 6 minus 3 is 3, squared is 9, plus 2 is 11. The same thing, our inverse here. Just flips these. The graph goes to 3, 2. Oops. I did 2, 3. So 3, 2, 4, 3, 5, 6. 6, 11 won't fit on my graph. And then my inverse, we know, is half of that sleeping parabola, or a square root graph. And then notice this one, it still has this same line of symmetry. And anytime they cross, that point would be on your line of symmetry. So again, that's the line y equals x. And then same thing with our equation here. So the original equation, the first step is to subtract 3. The second step would be to square it. And the third step would be to add 2. So subtract 2, square root, and add 3. Again, typically when we undo the square root, we have the plus or minus, but we don't want the plus or minus here because we only want half of this graph. We don't want the whole sleeping, we only want a square root graph, not a sleeping parabola graph, so that we can have a function. So the equation here is x minus 2, take the square root of that thing, and then add 3 to all of that. Where our domain, if we look at the graph, it's our x values, it starts at 2. So x is greater than or equal to 2. And our range is our y values. Y is greater than or equal to 3. Which, same thing, we saw this yesterday, our domain and range switch. Here, domain was greater than or equal to 3, range was greater than or equal to 2. And here the domain is 2, and, or greater than or equal to 2, and the range is y is greater than or equal to 3. All right, I'll leave it there for a couple seconds before I flip the page. So I'm just going to copy the equations down. It says Adriana and Statler are writing inverses of some functions. They came up with these inverse pairs. So again, these are just the ones from the book. Minus 15. So Number 1 is 3/5 x minus 15 with g of x equals 5/3 x plus 25. Number 2, j of x equals 2 over x plus 10. K of x is 2 all divided by x minus 10. Number 3, e of x is x minus 10 squared divided by 4, and d of x is 4 times the square root of x plus 10. And then last one, last pair, m of x is 2 times x minus 1 cubed plus 7, and p of x equals the cube root of x minus 1 all over 2 plus 7. You don't necessarily need to copy all of these down if you already started fine. We're just going to go over it briefly. So just looking at those pairs, which ones, don't do any math, just kind of glance at them. Which ones do you think are inverses? 1, 2, 3, or 4? There's more than one. There could be more than one. So I'm going to wait for you guys to kind of say it in your chat. And you can, unless you do the math, a lot of people do end up missing this. I just want your instinct. When you look at these pairs, which ones do you think are inverses? Okay, so thank you to those of you that responded. Quite a few of you actually. So how do we check? So it just says to check. What could we do? So we have a couple of options. We could undo the function step by step. So that would be using the equation. We could see if the tables are reversed. Kind of put a question mark. And then graphs are reflections across y equals x. So those are the 3 ways we can check if these are inverse pairs. We can test a point. The thing is, just testing one point isn't enough information. It will tell us if they're not an inverse, but if I test one point and it's true, then that doesn't mean it is the inverse. You'd have to make sure it's true for every point. If it's not true, when you plug it in and then the output you plug into the inverse. If it's not true, that shows they're not inverses, but it doesn't show that they are an inverse. So you want to be careful with just checking a point. That's what we like to do at the end to test to see if they are, if we did it correctly. So I will tell you that 1 and 2 are inverses. 4 is not an inverse because, and this is just by looking at it, if this has a -1, this equation has to have a +1. If this has a +7, this equation should be -7. So that's one way we can tell just kind of by the steps. And so I want to point out, again, we can go through and check all of these. We could use any of these methods. We could make tables. This one doesn't look like the inverse because this has a 15, this has a 25. It kind of gets a little bit weird, but that's the way the fraction ones work, because when you end up distributing, I'm going to show you what one with a fraction. I'll just do number 1 here with the steps. So again, my steps here, the first thing I would do, instead of writing multiply by 3/5, I'm going to break that into 2 steps personally. You can write it as multiply by 3/5, but then you have to divide by 3/5 later, which gets a little bit trickier. So you would multiply by 3 and then divide by 5. So again, say I told you x was 10, you would do 3 times 10 is 30, then you would divide by 5. I'll show you with the fraction too if you prefer it that way. Then your last step would be to subtract 15. So for the inverse, the first step would be to add 15. Then we would multiply by 5. Then we would divide by 3. So this equation is x plus 15 times 5 all divided by 3, which I just said this was the inverse, but when we wrote our equation, I wrote it like this. Well, if I distribute and simplify, I have 5x plus 75 all divided by 3, which is the same as 5/3 x plus 25. So this equation and this equation are the same. But when you look at it, you'd wonder, where does that 25 come from? So you can't just look at them and always tell if they are or aren't inverses. And again, if you like the idea, if you're okay with multiplying by a fraction, if that makes sense to you, awesome. You can ignore this. It shouldn't take but 30 seconds or so. If you want to say that we multiply by 3/5 and then subtract 15, well, here we would add 15 and then divide by 3/5. But hopefully we know with fractions, dividing by 3/5. So this would be x plus 15 divided by 3/5, which dividing by 3/5 is the same as multiplying by 5/3. That's what we do, because when we, again, if this top way made sense, awesome. And if you like fractions, most people don't. If you like fractions, you can pay attention to this. This is the same as divided by 3/5. Fraction bar, that division guy, which we could then write as x plus 15 times 5/3. And same thing when you distribute and simplify, you're going to end up with that. But I think it's more confusing to write it as a fraction. That's why when you see those fraction problems, I'd recommend breaking it into 2 steps. Pretend like you don't have a calculator. If x is 10, 3 times 10, and then divide by 5. All right. So I think that's it for our classwork today. Your homework is a little bit shorter, actually. It's 45 to 48, and then problem number 51. So you're skipping 49 and 50. But this is it on inverses. So if there's something that doesn't make sense, please ask. If you need me to go over something, I'd be happy to. Or if you have other questions, I'd be happy to do that too. Otherwise, you are good to go, and I will see you Monday. Have a good weekend. Yes, 2 is an inverse even though it divides by x. So that one we don't necessarily know how to write the steps for, but if we made a table or graph them, we would see that the tables are reversed and that the graphs are a reflection across y equals x.